Well, hello, good morning. Welcome to another fun episode of Fun with Physics. So today we actually want to talk about work. No, you don't have to watch me work out. And we want to talk about specifically how do we calculate work and how does it relate to distance, because that's the big thing. The distance needs to be parallel. So we're going to not use this 10-pound dumbbell, but just realize when you have a weight, gravity pulls downwards on it. The force of gravity is always perpendicular to the surface, and it's always towards the center of the earth. And so instead of using that 10-pound dumbbell, we're instead going to use this mass here. Now this mass is brass, and it has a mass of 1 kilogram. But what you need to realize is kilogram is not a unit of force. Newtons is the unit of force. And so gravity pulls downwards on 1 kilogram with a force of 9.8 newtons. Newtons is much like pounds. So remember that. And so if we remember, our equation for work is work equals a force times a distance. And this has to be parallel. That distance has to be parallel. That's great. This distance has to be parallel. Work equals force times distance parallel. What I mean by it is, if I was to go over here and I was to continue my workout and I was going to say, okay, well, I'm just going to go back and forth this way, and I'm going to move this half a meter from here to there, half a meter. I'm gonna have a distance of half a meter. Well, what would my work be in that case? Well, although the force would in fact be (9.8 newtons, the distance that this is traveling parallel, which direction is this force? The force is downwards. The distance would actually be 0 downwards. I'm staying horizontal, so there the distance would be 0. Well, what would it look like to actually do work that, from a physics standpoint, would have a parallel distance with the force? And that would be if I was to lift it up and down this way. So if I start here and I lift up half a meter, well, now my force would still be 9.8, but now my distance would be parallel with that, because the force is this way, it's downwards, force is that way, remember, it would be parallel, and so the distance would be 0.5 meters, and now I would have some work done. We could calculate that, and that would be something like 4.4 joules. Now, one other thing that's just slightly interesting that I should point out, and this is a higher level, so if you're not interested in a higher level, feel free to pause it now. But it's interesting to note that work is equal to the transfer of energy. Okay? And think about the GPE, gravitational potential energy, down here versus the GPE up here. How do you calculate gravitational potential energy? Well, you calculate gravitational potential energy. In this case, it would be the change in height times the mass times gravity. Now, check out what we actually would have done to do this. How did we get this 9.8? Well, 9.8 is mass times the acceleration due to gravity, which is 9.8, which gets us to 9.8. So this force is actually this, and then this height is basically your distance right here. And so the force, when something is just moving vertically, and oftentimes we'll think about that, the force times the distance is also the exact same inputs as finding the gravitational potential energy change, which would translate, because work is also equal to the change of energy. Thank you, like and subscribe, and I hope everything works out for you.